All right, let's jump right in. We're about to go on a journey from the total Wild West of early programming to the structured digital world we all live in today. This is really the story of a revolution in thinking that changed, well, pretty much everything. Seriously, just think about your phone for a second. The banking app, the games, your social media, they're not just apps, they're these massive, unbelievably complex pieces of software. So what's the secret? How can one simple, elegant idea manage all that complexity and just make it all work?
Well, that secret is right at the heart of our story. It's all about a revolution in how we think about, organize, and write code. It's the fundamental shift that took us from total chaos to clarity.
Now, to really get why this was such a revolution, you first have to understand the problem they were trying to solve. In the early days, as software got more ambitious and way more complex, so did the challenge of managing it. It wasn't just messy, it was pure chaos. And this question right here, this is the big one. This is what kept developers up at night for decades. How do you build something absolutely enormous, with millions of lines of code, and make sure the whole thing doesn't just collapse under its own weight? The answer, of course, didn't just appear overnight. It was a long, slow evolution, a constant search for better, more organized ways to build software. And that journey looks a little something like this. We started at the very beginning, with machine language, the raw ones and zeros that a computer actually understands. Then we got a bit smarter, with the procedural approach, grouping instructions together. By the 1970s, structured programming was a huge leap forward, but as software complexity just exploded, the old ways weren't cutting it anymore. A new idea was needed, and in the 1980s, it finally arrived: object-oriented programming. Okay, so let's zoom in on that step right before the revolution, the structured approach. And don't get me wrong, this was a massive deal at the time. But as we're about to see, it had some pretty serious cracks in its foundation. This image here shows you the core idea perfectly. You take a big program and you chop it up into smaller, bite-sized pieces called functions. And these little functions can all talk to each other. For its time, this was a total game changer for keeping things organized. But, and this is a big but, here's the catch. In this model, the data, the actual information, and the functions that used it were totally separate. It was like leaving your house keys out on the front lawn. Any function could come along and mess with any piece of data. As programs got bigger, this was a total security nightmare. And this is where everything changes. This is the revolution. Object-oriented programming, or OOP, came along with this totally radical idea. It asked, hey, what if we stopped leaving the keys on the lawn? What if we bundled the data and the tools to work with that data together in one safe little box? And this is the perfect way to get your head around it. Think of a class as the blueprint for a car, right? The blueprint itself isn't a car. It just defines what a car is. It says, a car has wheels, an engine, a color. Then, the objects are the actual real cars you build from that blueprint. So you have a specific green Polo, a blue Mini, a red Beetle. They're all cars, sure, but each one is its own separate thing, its own instance. So yeah, that's what a class is, really. It's the blueprint, the template. It lays out the rules. Anything made from this class is going to have this data, and it's going to be able to do these things, its functions. And the object? That's the finished product. It's that little self-contained box we were talking about. It holds on to its own data and keeps its tools, the functions, right there with it. And that, right there, is the huge shift. Data is no longer just floating around in the open. It's protected. So let's just put them side by side. On the left, you've got the old way, structured programming. Data and functions are separate. It's a free-for-all, which means really low security. On the right, you've got OOP. Data and functions are bundled up tight inside these objects. This gives you high security, thanks to something called data hiding. It's like putting your valuables in a safe instead of leaving them on the coffee table. Now, this whole idea of protecting data went from being a good idea to absolutely essential when the internet exploded onto the scene. All of a sudden, programs were connected to everything, and they were vulnerable like never before. This new way of thinking, OOP, needed a language that was built for this new connected world, and that language was Java. And Java came with this killer promise. Its slogan was, write once, run anywhere. Just think about that for a second. In a world full of different computers running Windows, Mac, Linux, the idea that you could write your program just one time and it would work on all of them, that was a total game changer. And the reason Java could deliver on that promise is because it was built from its very DNA on these OOP principles. It wasn't just a feature tacked on later. Being object-oriented is what made it so secure and so strong. That whole idea of objects protecting their own data naturally prevented all sorts of bugs that used to plague older code. That, plus its clever design, is what made it so portable and delivered on that run-anywhere dream. So, what was the secret sauce? How to pull off this magic trick? Well, it was actually pretty clever. You'd write your code, and the compiler would turn it not into code for one specific computer, but into this universal, intermediate thing called bytecode. And then, any computer that had this little translator program, a Java virtual machine, or JVM, could run that bytecode. Simple, right? But absolutely brilliant. All right, let's bring it all together. We've gone on this incredible journey all the way from the raw ones and zeros of machine code to these elegant, powerful little building blocks, these objects that literally construct the digital world around us. And that's the big takeaway here. That's why this all matters so much. This massive leap in how we think, from just writing a long list of commands to creating a world of these little interacting objects, that's what makes every complex, secure app on your phone possible. It is the very foundation of our digital lives. So, for decades now, this object-oriented way of thinking has been king. It built the world we live in today. But, technology never, ever stands still. The journey isn't over. Which leaves us with a really fascinating question to think about, right? What's the next big idea? What revolutionary concept is going to build the world of tomorrow?